Justin Mayer. Thanks.
Thank you for the introduction. So today I'm going to tell you a little bit about some adventures that myself and some of my colleagues had with trying to keep our servers secure. I will try to speak slowly. Unfortunately, io non parlo italiano bene, so I'm going to do this in English. And if you have trouble following along, please let me know. Raise your hand. Tell me, hey, you're going too fast. And I'm also going to try to leave some time for questions. So I would love to learn a little bit about how you have had to deal with some of these topics, because I think that it's an important topic for everyone. So just a little bit of foundation for this talk. Some familiarity with Linux package management will be useful, but not strictly necessary. Understanding a little bit about how a Docker container works is also useful, but that's more of a brief sidebar conversation later on. So again, useful, not strictly required. So 2014, as you may know, was not a great year for security. We had such lovely things like Heartbleed and this one called Shell Shock, otherwise known as the bash bug. And if you were doing any kind of server administration, you remember bash bug fix part 1, 24 hours later, bash bug fix part 2, and then another day later, bash bug fix part 3. So this got to be kind of annoying, as I will get into later. Poodle and Ghost. Am I the only one who thinks it's a little weird that someone comes up with these cute little cartoon images for these very serious security vulnerabilities? I'm not quite sure why we're doing that, but apparently we are. So why were these things so serious, and why did they even come up in the first place? This is what people who don't really, that are not involved in the software world, this is what they think of when they think of software. Anyone who has spent a significant time dealing with software knows that this is the reality. This is what your average piece of software is like, and it goes from, it's all layered on top of one another. You have, your hardware and your operating system, and it's just one layer of this crazy junk of software piled on top of another. And the result is that there's this risk of security vulnerabilities that can be exploited. And the reason why you might care is there are a lot of people here that are writing applications, whether that's in Python or any other language, that are deployed on servers that are vulnerable to these kinds of risks. And so if you're deploying something that you've poured your heart into, and sometimes you are betting your business on, the last thing you want is for one of these vulnerabilities to be exploited. So unattended upgrades are the first line of defense. I'm going to be focused a little bit on Debian and Ubuntu Linux servers, because that's what I'm most familiar with. So for those of you that spend most of your days working with Red Hat or Arch or some other distribution, I'm not exactly sure how unattended upgrades are handled on those distributions, but the general principles, in theory, should at least still apply. So unattended upgrades are not always unattended. That's the theory, is that they're supposed to be unattended. And we'll come back to the reasons why. But do you remember physical servers? Some of you may actually still use them. The last time I had to go online and order a server, and it arrives, and then you say, okay, well, I'm going to install the hard drives, and I'm going to put the CPUs in, and put the RAM in. When was the last time any of you did that? Recently? Recently, well, that's good, or not good, depending on how you feel about it. But increasingly, for me and my colleagues anyway, we're doing a lot of things using virtual private servers. So whether that's Rackspace or Linode or DigitalOcean or insert your preferred provider, you're using something that's very far removed from physical servers. And when you had these physical servers, they would often come with a plastic disk, or you would download an image and burn it to a plastic disk and then put it in the drive so that you could install the operating system. And when you do that, you get this guided installation where you're asked, okay, put in your name, put in your short name, put in your password, what packages do you want? And as part of that process, you get unattended upgrades. But from this shift from physical servers to virtual private servers, with an optimized one-step OS installation, a lot of that is lost. And what happens is the provider does this for good reasons. Like, they want to provide you with a streamlined installation. You say provision instance, and you get your instance, but you're not asked things like, do you want unattended upgrades? They just kind of hand you what they think are reasonable, sane defaults. And the interesting part is that as part of that sane default strategy, it's safer not to provide upgrades automatically. So many times when you're provisioning these instances, this is actually not enabled by default. So the result of that is that your system is vulnerable, and more than likely, you may or may not even realize that. That is not the right slide. So because you don't get it by default, you can install it manually, and you should do this. So on a Debian or Ubuntu system, you would run apt-get install unattended upgrades. Right? That's easy enough. Or is it? Because when you do that, you'll find that you've installed the package, but it's not enabled. And this is something that we found out the hard way. We're used to the previous world of the physical server and this plastic disk install, and the unattended upgrades all get installed and enabled. But in this environment of virtual private servers, you are not actually getting that. And when you install it, you think, okay, I have now installed unattended upgrades. But what you don't realize is that installing it is just half of it. It doesn't actually do anything after you install it. Why that is a whole different problem. But so you think that you're covered. You think that you've got it all installed, but you're probably wrong, because in my experience, that's just not how it works in this particular environment. So, well, how do you address this? You have to manually edit a text file, like you do for almost everything involving Unix of any kind. So it's fairly easy to enable it. Again, this applies to all of the providers that I've used: DigitalOcean, Linode, Ramnode, some of the others. You have to do this. You have to edit this text file. You have to add these lines to actually turn on the unattended upgrades. Again, the physical disk-based installer does this for you, but if you don't use that, then you have to do this. So you've installed unattended upgrades, you've enabled it by editing the text file, everything's fine, except if it's a kernel-level security vulnerability, because then you have to reboot in order for that fix to take effect. And you may have seen this yourself if you ever log into a server and it says, system reboot required when you log in. And just an interesting sidebar, I find it fascinating that the only way that you would know that you need to reboot is because of that message of the day that appears when you log in. So if you don't log in frequently, you would have no way of knowing that you have a reboot outstanding, that you need to reboot in order to have the security patch applied. And the same also applies for outstanding updates. If you, for example, you ran apt-get install unattended upgrades, and you think you're fine, and you log out, and you don't come back for a month. Sometimes you don't log into servers frequently. If everything is running, why would you need to? And you log in, and it says 84 security updates available. And again, if you didn't see this message of the day that appears when you log in, you wouldn't know at all that you had that many security updates outstanding, or that you even had any. So with rebooting, kernel updates require a reboot to take effect. So how do you know? As we just covered, you know when you log in. There are two solutions to this problem. There's a built-in way to be notified via email when there's a system reboot required, but you have to set that up manually. Not surprisingly, the method is the same. You go to some random text file somewhere and you edit it such that I want email notifications. And the other one is automatic reboots. Now, you may not be particularly excited about automatic reboots. Anyone ever restarted a server and then found that a service did not come up as you expected? So, given that basically anyone who's ever touched a server has experienced that before, you may not want automatic reboots. I know that that would make me very nervous. And so, there's this question of, okay, well, what about live kernel patching? That's, I don't know if you've been paying attention, that just landed. This is a link to a commit by Linus Torvalds that merges this branch with live kernel patching into the core. And the good news is that we now, in theory, have the ability to do that. But there are some gotchas. And one of those is it's not here yet. Okay, so it's in the repo somewhere, but it's not in any version of Linux that you're using today. And realistically, if you're running some type of long-term service like an LTS release of Ubuntu or something similar for another distribution, then you don't have access to this yet. And realistically, it's not going to arrive in a mainstream long-term service release for quite some time. And the other issue is that even when it does appear in the next version of your distribution of choice, it's not likely to be enabled by default for the same reasons that you may not want automatic reboots. A lot of people who do any type of systems administration or DevOps, whatever you want to call it, they're not really a big fan of this automatic, it doesn't matter what it is, whether it's an automatic reboot, an automatic kernel, live kernel patch, anything that occurs without their interaction makes them nervous. I gave a variation of this talk at the Southern California Linux Expo, and after the talk, someone came up to me and said, if I did what you, Justin, recommend, here, I would get fired. And I found that very interesting. And I said, okay, well, why is that? And he said, well, we administer, 10,000 servers, and if we had something occur automatically and it went wrong, all of our servers would be offline, and I would be out of a job. And of course, my answers to that is, I understand everyone has to balance between, unexpected behavior as the result of some type of automatic process. And I said, but the flip side is, if your system is vulnerable and someone gets in and deletes all of your data, steals your data and publishes it online somewhere, knocks all of your servers offline because they have root level access, choose your risk. Which one do you prefer? For me, I prefer to have it occur automatically. I have monitoring in place So if a critical service goes down, I am notified, I can then go fix it. But the flip side is that, how do you know when your stuff is vulnerable? How do you know when there are security patches or vulnerabilities that you may not be aware of? And that's the whole reason, for this talk. So what does this have to do with Python? 2 points. One that I raised in the beginning is a lot of us use Python for web application development, whether that's Django or Flask or TurboGears or Pylons or whatever your preferred framework is. A lot of us develop web applications, and we deploy those applications, and the last thing we want is for any of those issues to affect what it is that we do at the application level. The other reason is that, interestingly, Python can be used to address some of the shortcomings that I have brought up. So I don't know how many people who use Debian or Ubuntu and who more than likely also use, whether you realize it or not, unattended upgrades. But unattended upgrades is actually written in Python. I've been using unattended upgrades for years, and I had no idea, because why would I need to know? It updates my software, it keeps my systems up to date. I don't really have much reason to know that it is written in Python. But when I was trying to figure out how we could make this process better, I discovered it is indeed written in Python. There is, and so one of the things we wanted to do was to say, okay, well, if it's written in Python, maybe we can access it directly. Maybe we can use it. Because there are some downsides. There are some things that unattended upgrades doesn't do really well. And we considered, well, we could just, and I asked other people, I said, what do you do? And someone said, well, we have a bash script that goes through all of our servers and says, are there security updates here? Are they there? And then they manually do it. And we thought about just replacing unattended upgrades, but if we can, we would prefer to use the framework that Debian and Ubuntu have already put into place. So this is a really big hack. The problem is that the unattended upgrades package was named with a hyphen in it. So it's unattended-upgrades. That is not a valid module name. So you can't just import it as is. So this is just a snippet of code we wrote that essentially symlinks the path, and we give it an underscore instead of a hyphen, and this allows us to import the module and use it. It's a hack, but it's a useful hack. And then when we want to actually use it, we can go ahead and import it. If we have trouble importing it, we raise an exception that says we can't import it. And this shows just a little bit, and again, I'm only trying to include a brief snippet to show how it can be used, but it allows us to leverage, to make use of the parts that are already there. So for example, checking the allowed origins, checking which repositories unattended upgrades is allowed to access in order to do unattended upgrades. It allows us to tap into that, and then the same with blacklisted packages. So if there are particular packages that you don't want to be automatically upgraded, you can maintain a blacklist. So as much as possible, we want to extend the existing system rather than trying to replace it. And so while we were poking around and trying to figure out how to do this a little bit better for us, we wanted to try to automate this process. And so one of those ways that we're doing it is to use a command line interface tool called Click. Have anyone ever used Click before? It's by Armin Ronacher, who's the author of Flask and a number of other very useful Python tools. But it's one of many command line constructor tools. But it's one that we found very useful for this process. And the way that it's meant to be run is you run it on a server once. It spits out a cron snippet for you to put into your cron list, and then that automatically every, whatever the period is, will transmit the state of that server to an API that we have listening on the other end. This tool that we're distributing, as you may know, Python packaging is a little messy. And so when we were trying to think of how can we distribute this tool easily in terms of getting it onto our various servers without having to pip install requirements and having all of the different pieces potentially either installed or not installed. So we're distributing it internally via something called a PEX file. Has anyone ever heard of PEX? Excellent. It's good to hear. At least I had never heard of it until we were trying to come up with a solution for this, because we considered maybe we should do this in Rust, or maybe we should do this in Go, where you get a compiled binary that you can just pull off and put somewhere, and you just run your executable, and everything is great. But there's a lot of really interesting things that you get for free with Python, including being able to import unattended upgrades, including a number of other useful libraries. And so we really wanted to try to stick to Python unless we had a good reason not to. And PEX bundles all of your dependencies together into one zipped file. And so you can run foo.pex as if it were just a standard pre-compiled executable without having to pip install anything, and it works very well in our testing. And then on the other end, we're using Django and the Django REST framework to receive those updates. So that tool, automated via cron, sends information about the various servers to the REST service listening on the other end. So this is a very brief sidebar into Docker security. People are starting to get excited about Docker for various reasons. It introduces some challenging issues that are not really covered by the things that I've just described. It's a very different problem. So the things that we just learned don't really apply to Docker containers. You can't just run unattended upgrades inside a container. It usually, in theory, you could have some type of supervisor process that goes and makes sure that these containers are up to date. Generally, that's considered bad practice. In an ideal Docker world, you're supposed to have a single process, in each container. So what is Docker's equivalent to unattended upgrades? So I asked some folks at Docker about this question because it was something that I was curious about. And the answer is that you use chained webhooks. In the Docker repository, you can mark an upstream repository as linked. And when you do that, when your upstream image, say you're using, it doesn't really matter, Postgres. When your upstream image is updated with the latest security update, then your linked chained image that you have as part of your build process will be automatically built to include that security fix. But that's only half the solution. The other half is actually updating the container itself, because your container is just a snapshot. It's a running snapshot, of your image, and you still need to pull in the image and respawn your container in order to pick up the fixes that were automatically applied to your image. So I mention this because you don't get this for free. You don't get it automatically when you decide to change your deployment solution to Docker. So it's just something to keep in mind before you get all excited and you think, oh, we're going to switch everything over to Docker. Just keep in mind that it's going to require some extra work to figure out how to automate the respawning of your containers for, in order to include these security updates. When I spoke to Jerome at Docker about this, he said that it is something that they know is an issue, and whether that is fixed within Docker itself, or whether it's left to the broader Docker community remains to be seen. But he and other people seem to think that this will be addressed at some point in the near future. So that's what I wanted to explain a little bit in terms of how we had this issue of how do we tell which of our servers are up to date, which ones are not. But I'm very curious to hear a little bit about how other people solve this issue. How last year when we had all of these security problems, how did you deal with these things? So whether it's telling me about your own experience, or if you have any questions about anything that I asked, by all means, please let me know. I would love to talk about it.
Thank you, Justin.
What's the average life cycle of a server we're talking about? Because from advertising industry where I am, normally we have projects spanning through 3 months, where upgrades are not that relevant. So because we don't have in-house ops most of the times, it's easier just to keep it running until it dies, and maybe be sure that the data security is delegated to something safer, as in safer, whatever, encryption or something like that.
Sure. So I'm going to rephrase the question to make sure that I understand. The question was, about the life cycle of the process. It's a question of how you handle your deployment. Some people, if you're deploying to something like Heroku or a platform as a service, you are implicitly outsourcing the management of the operating system layer. You're saying, I don't want to deal with any of this. I want to pay someone else to deal with this. And that's fine if that's what you're doing. I raise these issues because a lot of people like me are using actual operating systems. We're deploying things on instances of Linux, and those things are not taken care of by somebody else. In terms of the life cycle of a particular server, I mean, we have servers running an LTS release from as far back as 2012, I think, precise, if memory serves, is 2012. And with a 5-year span, that means that long-term service, promise ends in 2017. So we have 2 more years before we are forced to upgrade that machine. But, the life cycle, at least for us, is actually quite long in terms of keeping track of, security vulnerabilities.
Wouldn't it be cheaper if you have a fleet of servers in the order of 1,000 servers to re-release on 1404 LTS, for example, and just drop the old fleet and recreate a new one under a new load balancer, for example?
Sure, you can certainly do that, but I would make the argument that does not come without a cost. Oftentimes, the stack that you've developed may require changes. It doesn't always, you can't just pick it up and just drop it on, on Trusty, or Jesse or any of these other releases and know for a fact that it will function without further modification. So, but I mean, really, I think that what you're describing is orthogonal. It's a different type of issue because this is more a question of, how do you know when your systems are up to date and when they aren't? Because it doesn't matter whether you can move to Trusty or some other later release, you still have the same problem. It's not a question of whether or not security updates are available, it's knowing when they're available, and it's knowing whether your stuff is up to date or not.
I'd say the big problem is timeliness. That in the case of the kind of threats that you mentioned, you really have to react immediately. And even, well, in an ideal world, you wouldn't use automatic upgrades because you would want to vet the upgrades, make sure that they fix more than they break, and then, only then, install them. But the problem is there's a trade-off in the time you can take to check the upgrades and the time that you are exposed to that kind of risk. So it's true. It would be probably cheaper in the ideal world where you can vet your upgrades to actually say, we are not upgrading for 6 months because every 6 months we move to the new release. If you can only wait, well, ideally minutes, but not more than hours, that's not possible.
Right. Yeah, and relating to that point, even if you do everything that I described here, unattended upgrades by default runs every 24 hours. So let's say that some critical 0-day, all of your stuff is going to crash and burn potentially if someone happens to find your machines and understands that they can exploit it. If that vulnerability, if the fix for that vulnerability comes out, but unattended upgrades is not scheduled to run for another 23 hours, your systems are vulnerable for that entire time. And that's, for many people, that's an unacceptably long period of time. And so, one of the things that we're trying to do is try to figure out how to solve that. How can like this is something that we need to address right now. If you are interested in following our progress, you can go on Twitter, it's @Monitorial. You can go to monitorial.net. We're trying to figure out how, we're trying to fix our own problem. And if we can fix it in such a way that it's useful for you, all the better. So please, let me know what you think.
So maybe a small follow-up question. You are using unattended upgrades for your basic services, but I assume that your Django projects, for whatever reasons, are using a virtual environment? Or are you using the system-provided packages, and how do you upgrade those? Because usually developers I work with are like, okay, the packaged version is way too old, and on a related perspective, security updates, especially for Ubuntu, come like 1 week later. So especially in the context of a web application where we have statistics for Drupal, and there are like automated scanners after 7 hours, so you have a time frame of 7 hours to react. As you said, unattended upgrades won't help there, and if you don't use system packages, it doesn't help either. What's your idea on that?
That's a very good point. There's a trade-off, as there almost always is, between using the system level packages and, say, managing those packages yourself outside of the distribution's package manager. And where you fall on either side is largely, a question of preference and priorities. And it's a complicated question because it's more than just security. You may need a later version of a particular package than your distribution provides, in which case your hand is forced. You generally have to manage that yourself, either in a virtual environment. But whenever possible, we use our own environments. We usually don't rely on the distribution's Python packages for the reasons that you mentioned. Often, we want to be able to get that up and running as quickly as possible without having to wait for Debian or Ubuntu or someone to release the patch. And again, knowing when that you need to do that is a whole nother issue. How do you know that that the requests library that you depend on has an outstanding security vulnerability? And that's something we would love to address at some point. At the moment, the goal is the lower level of the operating system layer. If we figure if we can get that covered, then we can work our way up to the application layer. But you're right, that is a very significant task. Anyone else have any comments, questions?
Sorry, with regards to the Docker, when we said we have an upgrade required for fix a vulnerability issue at the level of the kernel, I suppose you still need to put that upgrade in the virtual machine running Docker. So still you have the same issue as with the virtual machine or the physical machine as well.
Perhaps, at least at the, if I understand the question, at the host level, you can have things like unattended upgrades running at the host level. So if you're, if you're running Debian or Ubuntu and you, trying to think of, let's say, OpenSSL library. There's a new vulnerability, there's a patch. Unattended upgrades can install that. You don't have to do anything. The Docker container is not using that. It has its own, it's based on its own image. So generally, the whole point, the whole purpose of the container is to be isolated from the host environment. Any vulnerabilities that are fixed in the host should be taken care of by unattended upgrades. It's that isolation in some ways that is the problem, because the isolation that you get means that you have to fix those issues irrespective of what goes on in the host. Right? Or do you have a...
I thought there might be something from the kernel level which are used by the isolated, let's say.
No, that's actually a good point.
Docker. So I suppose it inherits the fix that you do on the host level.
That is true. And again, to the extent that you have live kernel patching, in theory, that should extend all the way through from the host to your Docker environment. But that's an interesting question. That's, I assume that that's how it would work. But perhaps, now you have piqued my interest, and I will reach out to Solomon and Jerome and see if they have an answer to that question. But I hope that it works that way. I hope that the live kernel patch would extend down to the Docker layer.
Are you using some software like Ansible or Salt to help you in this process? And if so, how much this help you?
That's an excellent question. We do indeed use Ansible for our base configuration management. The question relates to how do you configure when you have, even if you have one server, much less if you have many, how do you ensure that these things occur in terms of, manually editing text files is not fun, and it's not what you should be doing in terms of maintaining your production environment. And so we use Ansible, and so we actually have things like, we use the line in file directive. There's a module that's included with Ansible that allows you to say, given, look for this line, and if, automatically install dates is 0, change it to a 1. And so we use Ansible to do this across all of our servers, and whether you use, Ansible or Salt or Chef or Puppet, doesn't really matter. The important part is that you do use one of those, because having a predictable, tool that you use across, to maintain a consistent state across all of your servers is definitely an important task, and I highly recommend it.
Okay, I think that we are almost out of time, but maybe if someone else has a very quick question. Okay, no more question. So thank you, Justin.